Hey, A&P students, welcome back. Round two of human tissues. Hope you really enjoyed looking at that simple layers, the simple epithelial layers, and of course the different types of cells. But we are back, and as you can see on our screen, now we're going to go from single layers or one layers to multiple layers. And even though the single layers are important, what you're going to see here is the most common types of cells, and once we talk about what they are, their structure and stuff and function, it'll make a little more sense of why these are the most common, or more common, I should say, than simple. But it's good old stratified. Stratified. Super important. And it's a pretty cool kind of assembly line type situation to go from birth to use to death. And but we'll get into all that. But again, welcome. Hey, thank you. Hope it's going well for you, everything you got going on. So we'll do a little bit about stratified. That'll take up some time, but our main topic of this video is connective tissue, and unbelievably important stuff, but you know that already. And so with that, let's get started. Now this one is, especially when we get to connective tissue, there's a lot more just words than pictures. So instead of putting you through the writing it, and it would just be hard to read, and even though I would be telling you what it is, it would still be hard to read. We're just probably going to type it out, make it that way it's easy to read for you as you collect your notes. So with that in mind, let's get started. I'll move this over here more where it needs to be. And well, first thing we want to talk about was stratified. Two or more, and you can probably hear the keyboard, but that's all right. Two or more layers. Obviously, we got to have at least two, or it'd just be simple. So you got to have those two layers. And so when we think about that, let me close this out. Get a little pen going here. Now let's go back. Let's go get some blue here. So obviously we're talking about just layers of cells, layers and layers and layers, and they have some pretty good functions or pretty good purposes, and we'll mention this. But when we talk about down here at the bottom, okay, that's where the new cells arrive, and that right there is why I'm typing it over here as opposed to writing it. One, it would just probably takes longer, and then they just kind of move upwards. Okay, and as they go up through the various layers, they develop. Okay, take more of their shape, and then of course when they get up here, this is where they die, and fluff off as skin cells. The old flake off, die, dry out, that kind of stuff. And it's some of that stuff is why people use those little brushes on their skin to kind of scrape all that stuff off. But it's just a cycle that they go through. So it's a continual replenishment with the new cells, and as they move up through the layers. So let me close this back out and go back over here. And yes, I want to edit because I want it done. All right, and we got all the types. Okay, we got squamous. Always want to put an I there. The O comes first. Cuboidal. Columnar. And we got a new type. And this new type is super important for a very good reason. But we will get to that when we talk about transitional. That transitional go back to my pen so I can do this. That transitional is right there, and we'll talk about that, but it's super important. I'll just say when it's in need, it's important, and that'll be your little clue right there. But yeah, it's a kind of a private moment, but we will get to that soon enough. Alright, so let me close this out, and let me slide over here. We're going to play a little game. Okay, we're going to play a little game. Yesterday, or last time I should say, we did these. We showed the pictures, and we kind of explained what they were. But now you've been, let's see, introduced, to the cell types and their shapes and stuff. Play a little game. I'm going to, one at a time, give you the details on this particular set of cells, and of course I've already told you the one down below there is transitional, so can't play the game down there. I already told you what it is. But as I unveil these details, let's see if you can figure out what type of cell it is as far as name. So here goes. Let me get a little dialog box here. Put this over here off to the side. Oh, I didn't catch it in time, I guess. Bring this over here. There we go. Alright, your first hint or your first clue is many layers of cells. And of course that's not really a clue because that's all of them. They all have that. Your second one produces sweat and some other kinds. Sperm. Oh, not an ovum. Ovarian hormones. That doesn't look right. Yeah, I don't need that A. There we go. Let's say that didn't look right. Okay, ovarian hormones, and that's probably not a great clue either, but this is the one that's going to give it away. Oh, forgot my U there. There we go. Square shape. And of course, boom, flash bulb should be going off everywhere. Hands should be flying up into the air. Square shape. So who's that got to be? That's right. Cuboidal. Cuboidal cell type. So when we think about that, obviously you can see, and let me get a little pin here. You can see the many layers. You know, think about it being a layer here, maybe a layer here, maybe a layer here, and then a layer here. So this particular one looks like it has 4 layers. And you can do the same thing over here. Maybe a layer here, maybe a layer here, layer here, and a layer here as well. And you can see that based on this cross section where it is, this of course is a hair follicle, so that would lead us back to the old sweat note right up here. But again, you can also find it in sperm and ovarian. And that still doesn't look very good. I think O-V-A-R-I-O. Yeah, that's right. All right, cuboidal. Okay, let me close this out and slide down here. Okay, transitional. Yeah, we're talking. Okay, so transitional is big. And let me get a little. All right, I'll put the word transitional here so you can see that. But this is transitional, or stratified transitional cells, and they're big because they can stretch. And when it's time to for them to stretch, you really want them to, because you're going to find them in the bladder, okay, and so in your reader. So when it's that time when you know You're feeling the need to go. You just can't. Maybe you can't. It's not a good spot. Maybe you're on the road. Whatever it may be, in a meeting, making a A&P video, whatever the case may be. Those things can stretch a little bit and still be okay. Go from that small round out to an oblong rectangle kind of shape. So they've got that ability, and super important when the time is right, or I should say not right, however you want to look at it. Alright, now we turn our attention to connective tissue. Let me get this a little bit bigger so you can just see how important it is. Connective tissue, what we're thinking about here is tough, durable, things that connect. Things obviously connect, that's what it gets its name from. But just really useful things, going to connect things to each other, support, protect, all that kind of good stuff. So let's get me a little box here, and let's start putting this in print so you can see what we're going on. Okay, so obviously it connects, and it connects organs to organs. Okay, so you've got things need to be held in place, use each other for support. The connective tissue is the tissue that kind of holds things together. Maybe the things around the stomach, it would connect those, hold them in place. So just a really useful tissue in that regard. And of course, I mentioned support, protection. And looking at my list, most common type of tissue. Most common type of tissue, and saving the best for last, lots and lots and lots of blood vessels. Okay, so it's super saturated with blood to keep it fresh, keep it new, keep it replenished, all that good stuff. And so super really important detail. Property. There you go. Property is the word I was after there. Now, inside of connective tissue, okay, not only is it the tissue itself, but it's got a lot of things in it, okay, that are super important. Keeping it vitalized, keeping it fresh, keeping it healthy, keeping it robust, vibrant, all those cool words you want to use. So let's take a look. Not a lick. We don't want to do that. Let's take a look at, you know what, I'm going to stop that. I'm going to get up here and make this a little bit bigger. There we go. So they got guessed. A lot of things inside of connective tissue. Okay, we'll start off with a pretty important one here. Fibroblast. Okay, fibroblasts are super important because they make, just I'm going to go a fancier word, produce. Oh, I left my C out there. There we go. Produce fibers. And I'm going to use that word fibers. It's a general umbrella term for a lot of things. And I'm going to finish my thing here, and then I'm going to draw a couple arrows because they're right over there, to the right over there. Produce fibers and ground substance. Oh. All right, it's like I'm going to have to move that word fibers. So let me close this out. I'm just going to go ahead and move this now so it doesn't get in our way. But when we're talking about produced fibers and ground substance, we're going to talk about those. I mean, there's fibers, there's ground substance. So if you're thinking, oh, what the heck are those? That's all right. We're going to get there. We're going to get there. Oh, ink tray's up. Now it'll do it. Yeah, let's get that dot out of there. That's why I was reading that dot. Yeah, I want to edit that because I'm not done. All right. Next guest, macrophages. Now, a lot of you are in the nurse field. Some of you are not. Some of you are doing other things. So hopefully the word macrophages is something that you're familiar with to understand. But these are simply cells that travel around, and their idea is to find foreign material and get rid of it somehow. So whether it's viruses, bacteria, anything that's not us, okay, they grab onto, phagocytize, in other words, take it in, and solve it with enzymes or whatever they may have. But they are foreign. No, I think I went wrong there. Missed my G. When you type as slow as I do, it's easy. You recognize misspelling really quick because you got time. Macrophages, getting rid of foreign material. Okay, traveling around. Think of these little warriors, part of the immune system. These little warriors just travel around, and when they recognize that something isn't us, okay, they get after it. And if you take microbiology, you'll get a big old dose of this, and actually an A&P. When you guys get to A&P2, you do the immune system, and that will be thoroughly explained by myself or Miss Nedler, most likely Miss Nedler. We'll take care of you on that, but some of this other stuff, the immune system as well, that will be covered heavily in that chapter. Okay, next guest. Okay, still part of the immune system. Leukocytes, okay, or more commonly known, white blood cells. Okay, and there's a couple types. So I'm going to go down here. I'm going to put a little deal here. So this is the type of leukocytes. The first one, neutrophils. Okay, neutrophils. These guys, these are bacteria hunters. Okay, they are traveling around, and they are a type of leukocytes, but they are bacteria hunters deluxe. So they just travel around looking for bacteria cells. Okay, and when they find them, okay, they get after them. Take care of them, get rid of them in whatever manner possible. The next type of leukocytes, lymphocytes. Went blank on the spelling there for a second. Lymphocytes. Oh, I didn't put my little dash in the front here to just remind you that these are a type of leukocytes. Lymphocytes, now they're also hunters. They're out there looking for the things, but they're everything else, more like toxins, viruses, I'm just going to leave it at virus. Okay, anything else, but foreign material, we'll just put that on there too. That kind of covers everything. Foreign material. I'll leave it singular. Okay, the next guest that are in there, we got 3 more to talk about. Plasma cells are found within connective tissue, and these cats are super important because they make antibodies. And that's a hot word right now. Okay, that's a hot word right now, and like I said, as you know, most of you in the nursing fields, you know more about the current situation, antibodies, but that's kind of one of the ways that they're testing for the coronavirus. Is if they can detect that the test can detect that you've got antibodies for the COVID-19, that means you must have had a little bit of it. And if you're making antibodies for it, you must have had a little bit to some degree. If you never really were sick, then you just had it a little bit. Didn't affect you, but you did have some. So, and your body made antibodies, which is good. That's what it's supposed to do. That's what you want it to do. That way, the next time it comes along, your body's ready for it and can do an even better job at keeping you safe and well. Next up, mast cells. Now, we mentioned that connective tissue has lots of blood vessels. Okay, we mentioned that right over here. Lots of blood vessels. If you're going to have lots of blood vessels, you're going to want these mast cells. Yep, I want to edit. You're going to want these mast cells because they're going to help out with the blood vessels. Okay, they're going to help induce clots. Okay, but they're also going to help dilate and constrict the blood vessels. And of course, you guys probably are pretty familiar with why it would do this. Of course, that's one of the aspects of it is just, changes in pressure, getting the blood flow, but more importantly, it's about the heat retention / loss. Okay, if you are too warm, change the shape of that blood vessel to release some heat. Not warm enough, open, change it again to try to collect a little more of the heat. Okay, the next player, the next guest in the connective tissue, last one, and that's the prefix of the word. So anytime you see that, okay, I'm just looking at my notes here. I don't. Okay. Adipocytes. Had 3 thoughts there at one time. Sorry about the delay there. But we're going to store fat. You see that addy prefix? You got adipocytes. You got to be thinking fat. So we're going to be storing fats in the connective tissue. Again, lots of energy. It is needed, and of course those are storing fats. Those are going to be a part of that energy process, storing energy, so when it's needed, it's there to be had. All right, so those are the guests that love to be in the connective tissue. And so now what we do is, let's go over here, and we'll leave that where we can see it. And then we'll move fibers over here, and then we'll put ground over here, and we'll talk about these just to make fibers a little bit bigger. It looks like it's off balance, but that's all right. And we'll make ground a little bit bigger, and we'll go up just slightly. Get that. There we go. Now we're in good shape. All right, give me a little box here. Move it over here. We'll do fibers first. 3 types of fibers. Collagenous, okay, most common, tough, flexible. So it's the most common type of fiber. Tough, flexible, and when you're thinking fibers, you're thinking most common, you're thinking tough, flexible. What should be popping into mind, tendons, ligaments are made out of collagen, as we know, as you probably know, and therefore collagenous fibers. Okay, our second type, reticular. Reticular fibers, super thin. I didn't put it. Let me go back up here and add that word right there, thick. Okay, super thin, reticular. Okay, and we're going to find these. I don't need two L's there. Spleen. Scan them in. Oh yeah, there it is. Lymph nodes. Be made out of reticular fibers. Okay, and our third type of fiber, elastic. So Elastic Man, the Fantastic Four, must have had a lot of this in him. So if we're thinking elastic, obviously what would come to mind first is it can stretch, but it also recoils. So think slinky, that kind of stuff. Stretch it out there, okay, and when it's ready to, when it's done, it recoils right back together there. Okay, it can also branch out, and I'm going to kind of draw this picture to make it. I'm going to put and rejoin, and I'm going to draw a little picture. It will be a simple stick kind of drawing, but just to emphasize that. So let me click out of that. Let me get a little pen here, and when I say branch and recoil, what we're talking about is the elastic fiber can be coming along like this, and then it can kind of split, and some of it go this way, some of it go this way, and then at some point in time, okay, it comes back together like that. So when we say branch and rejoin, that's what we're talking about. So let me just draw this right here. That's branch and rejoin, just so you can have that in your notes. So that's our fibers. Okay, so we're going to talk about our ground substances that we mentioned, and that's going to be our last section of connective tissue, and then we'll go from there. So when we're talking ground, let me close out this, get myself a little box here, move this over here. So when we're talking ground, there are three types. Now this first type is a super long name, so I'm going to start typing it. If you want to go get a sandwich, maybe take a walk around the block, go feed the dogs, whatever you got to do there, and just come back and perhaps I'll be done typing it out. But here we go. But glycosaminoglycans is its name. But here we go. If you're whistling, singing a song, maybe you'll get the song done before I finish. Yeah, super long glycosaminoglycan rolls right off the tongue there. But these are pretty unique types of substances. I don't want to say the word fiber because they don't need to go in the other column. But unique substances because they combine things that aren't typically combined. And I'll explain that here in just a second. But these are long substances and polysaccharides. Okay, long polysaccharides. So that tells you it's a sugar. Okay, but they also have amino acids involved, and that's where you get that amino within the name. So you've got sugars and amino acids kind of in the same molecule, and that's unusual. Unusual to combine those two. And let's see, what else do I got down there? Oh, function, water regulation. So remember, all this stuff is within the connective tissue. We're part of the connective tissue. So within the connective tissue, you got these long polysaccharides, got some amino acids, got some sugars combined there, and it helps the water regulation for the connective tissue. Okay, that's number one of our list of three. This one isn't really as long. Protoglycans. Okay. These last two, when you see the function, you're like, whoa, isn't that the same thing? But just pick up on all the words. It's slightly different. But this one, this particular substance, holds, should have put an S there, tissues together. Okay, so all those layers of tissue from the stratified and whatever combination, now these protoglycans are going to be holding all that tissue together. The last one, the first part of its name, adhesive, so spoiler alert, it's going to also hold things together. The glycoproteins, okay, and it holds components. Okay, so within the tissue, the components of it, so whatever is making it up, the adhesive glycoproteins holds those together. So the protoglycans holds the layers of tissues together. The adhesive glycoproteins hold components of tissues together. And so there you go. A nice little look at connective tissue. So with that, we will wrap up connective tissue, and our next topic, areolar tissue, that'll be reticular tissue. We'll get into those kind of things, and that will be our next topic. So until then, we will say goodbye.